I guess we'll go to do the pseudocode first, so at least we can run through the whole process. So, or not. Or we'll just go through it. Start, and stop. All right, so we have so it says write a C program that prints 5 times multiplication table for numbers 1 through 20. All right, so we need a number. Number. I'm going to need number. I'm going to need a counter, no? I'm going to need a counter, right? And we're going to need that's what we're going to need. That's all. We're going to need anything else? We're going to need anything else, guys?
We're not gonna put in like total equal, none of those stuff.
Yeah, because that's what they ask us to do. They say example of the expected output is this. Example of expected output. So we're going to have on the screen, we're going to have 5 multiplied by 1 equal 5. 5 multiplied by 2 equal 10, and likewise. So you're going, at the end of the day, you're going to look like a normal, you'll call it now.
Like,
yeah. So I'm just trying to pull up one. So I guess that's what I'm saying. I know definitely we're going to need the number. We're going to need a counter because we're going to use, I guess we can use different loops. So I think we can use a for loop. That's all. As I say, I guess I'm not doing myself for that.
Repeat until.
Okay, is a repeat until, yeah. Where do I prefer repeat until over a for loop? Technically, we can use any loop, you know. But why do I use repeat until over the for loop?
Wait, repeat until if you use it until what? It's correct or incorrect.
Yeah, until you have a value where we stop the loop.
So I guess we can use it until reach 20. The count reach 20.
All right, we just pull up this one. It's a while loop. While this is not a repeat until. Let me try to pull up a repeat until loop. Loops, iteration nodes. Yeah, well you're right, you know. But how do we come up with the 20? You know, we're good if we use a repeat until. You know, I try to look for an example. We did any repeat until in a class?
I don't think so. I think I want to research loops. Maybe read up on it.
All right, could try to do it using both.
Sure do any until in a class.
All right. Look on this. This is which question was this? Write an algorithm to enter the age and count the number of students in a class. Calculate the average age of students in the data terminated by. Is that part here? Terminated by value 999. Whenever we use a repeat until or a loop, whenever we use a repeat until or a loop, another type of loop, but we don't have the exact value. We have to have a terminating value. But the for loop, no, the for loop allows for a predefined number of loops before the program terminates by itself. You understand?
Yeah, but we can use a while loop, you know.
Yeah, but no, I know what I'm saying. I'm not saying no. All right, I'll show you something. My copy. So this is one of the questions from off of the when I want the teacher give it. So it says start. Hold on, I'm respond to the error. Not for respond. All right, this thing says so this question is I'm gonna copy the question. All right, so you see question there at the top. It says write a pseudocode that finds and prints the average of 10 students English grade. Start. I'm gonna indent them. Okay, incognito. So it says sum. Start sum equals 0. So you start with sum. For 1 to 10, do the following. It says for counter equal. If you notice, in a defined counter here, so the defined counter here, so it's a different variable, you know. For counter equal 1 to 10, do, and these are things you're going to do. You're going ask the person for enter grade, and then you're going to read the grade, and then you're going update sum, the variable up here is a sum. See that? Same variable. Going to update sum. And this now, all of this going to happen for this, all of this going to happen 10 times. Can you see it? For 1 to 10, it's going to happen for 10 times. And then you go end the for loop. And then after you end the for loop, you're going to still have the value of sum. And then now you have another variable now named average. I guess up here, so it would have good for define average from up here. So. And then now you're going to find the average equal sum divided by 10. You already know the value 10 because see it up here already. And then now, after you have everything, then you're going to print out average is whatever. Output the variable average. See the same variable average here. And then you stop. Just not necessary. So is it the advantage of the for loop is when you definitely know how many times you're going to do something, as opposed to a for loop now. As opposed to a for loop and the while, and as opposed to a while loop and a do while loop, where you still get a chance to do something. We could have said, while instead of say average not equal to 999, we could say while counter is equal to a certain value. Here, sir? You understand what I say? We could have said do everything while counter is equal to something. And then do everything. So we could have make a while loop function the same way as a for loop. You understand what I say?
In a way, yes.
Or you say in a way. Or in a way though, we could use both methods and work it out. And then we can look on the difference. All right, so all right, go back to the original something now. So I'll take off regard skin on this material. So it says start, but we take off all of this define. So which is what we're really doing. You know what? Let me read it. Let me leave it there as notes. All of them things I'm gonna leave as notes, you see? You can really do this in a pseudocode, but for the sake of understanding. All right, so this is all we have. So we say count number. We can say number equals 0. And then down here, so now we can say counter equal 0. All right. And what you want, we use the while loop first. When we use a while loop first. Huh? Talk to me now.
We can start with the while loop.
All right. So while welcome error. All right. So while end while. The reason I put it there so I don't forget. Okay, no, so while if you start with a while, I'm gonna go back to the other question. If you start with a while, you have to end with an end while. All right. So I'm just put it there from beginning. And the case, the case no all that, but let me just put it there for sure how we're being taught how to do it. But it doesn't matter because it's pseudocode really. All right, so say while so it's a counter is less than what 20, 20 times we're gonna do it, or less than and equal to. All right. While counter is less than or equal to 20, do. Cause we're gonna do something. And then now what we're gonna do now, we're going to I'm going to say, all right, let's introduce another variable name product equals 0. Good habit for initialize the variables. All right, then we say now product is equal to 5 multiplied by counter. And then we'll go print 5 multiplied by, I use x here so because all of this way in a bracket is a variable. Is it to go print out? And him same want it looking like this. Right?
Yeah, we see that part.
Yeah. And sometimes as you go, as you go along, you can pick up certain things. So I'm gonna do something here, so and then afterwards I'm gonna change it. 5 multiplied by 1 equal and then take a equal to product, right? Because product is this variable. So if me should I do this, I'm gonna say while counter less than or equal to 20. So we know so I'm gonna go through this 20 times. Although there's something with this. Do product equal, and we'll work out the product first. So this is calculate the product. So this aligner calculate the product, and then this aligner now a print out. Print. So this I go print to the screen. 5 multiplied by 1 equal. Print out the word product. But so far I see 2 things wrong with this, and then this I go happen. Hold on, and then after we're done now, then we have to go update counter, right? Because counter have to move. So it's a counter is equal to counter plus 1. So each time this loop go around, counter go up by 1, right? And that's all there is to it. So everything, the whole program will happen within here. So but two things are wrong with this though. We'll start with the while loop. Because you notice that it says from counter equal to counter less than or equal to 20. So the first value of counter what? What would be the first value of counter?
You have 0, but I think we should have started at 1.
Yeah. So that's the first thing we're wrong with this, because if this were to start, if this were to be left like this, would I do it actually 21 times? Because it's gonna start from 0, and then this one will have less than or equal to 20 here. So if we move this, if we move the equal sign, it would actually do it 20 times, right? And then it would go through. But there's another thing now. So we could do that first part there. Could change that to put this back. So we'll have counter definitely starting at 1. So it's gonna start at 1, 2, 3, 4, and then go up to 20. But there's something else though, because when the first time this go around, this it going to print out this and it going to be correct. Yeah. But when it go around the second time, when this upgrade, when the first time now, when this I got turn to, when counter go reach 2, because by the time I go around here, so for the first time, counter go be equal to 2. But when it go around again, it will print out 5 multiplied by 1 equal product again. The product going to work, the product going to be correct. But under this one, 5 multiplied by 2 the second time around. That's all.
So you have to put counter there so too.
Yeah. So instead of putting a constant value here, so I'm going to put the variable counter. So I'm going to cut this down now and say 5 multiplied by, put all of that in a literal. Instead of having 1 here, so replace this with counter. Right? And this should be okay. So now the second time it go around, it's going to be product. Product always going to calculate on the spot. So, and we know it's 5 we deal with already. So 5 multiplied by a counter. So the second time it tell us 5 multiplied by 2. And the answer going to be 10. So it's going to be say 5. This is going to print to the screen 5 multiplied by, and then print out this, which in this case would be 2, counter 2 equal, and print out the product. And that should be it. And each time we'll update.
Only the kind of one look like say I print a literal, so I got to show counter. Possibly you could use, what do you call that again? Use the percentage on one letter and then put the variable at the end of the line. So it basically replace whatever the end of the counter at that point with a variable name.
Okay, no, this is not going to be a oh, I'm going to get to it. So this is wrong. Wait, no, this is not wrong. We should put the equal sign in that because I deleted it from before. So this is the right thing. So this I go print out as a literal. 5 multiplied by, and I go wait for this variable counter. And then after I print out this variable, I go print out the equal sign. And then I go print out the variable. So in this line, counter, product are gonna be variables, and them in a quotation mark gonna be literal.
Oh, I see it now.
Yeah.
Those are things, so when you have one line like that, you only have one literal for the print line. So you can actually have more than one literal in it. Like you have something why exclude it from the literal, then something else starts.
You can have it. But remember this is pseudocode, So this can be you can do this a number of ways. You can't really do this attack. We put the percentage that attack.
Yeah.
That's what you're referring to. Percentage. Yeah, I could have done it like that, but the extra typing for me. They really need to do it. So all right, but go check if this gonna work. And then no, then we try it. Then we try using the for loop way. Because technically this should work. I could try it. Could drop in the thing I'm gonna stop share and start it again. Copy this. I'm gonna copy everything. Copy everything. All right, I'm gonna switch over the share and go to the dev program. All right, so where am I? All right, go again. Where is it? All right, great. So create a new source file and paste that in. You seen it, right?
Yeah, we can see a screen.
Okay. All right. So this are the same code I'm pasting at the div. So now we're going to write the C for this now. So of course we start to the header file. We'll make sure and put all this now. Put all of this in that. Comment out all of this. So not interfere with the program. All right. So we're going to include the header file. Yes. Awesome. I have int. Could there be a number of things? Main. All right, so we're ready now. So we'll start by defining all of them variables here. So yeah, there's only integers ready with simple numbers, so we're not going to go further than integer. So we'll say int count number, comma, or we can initialize all of them. Number, comma, number equal that counter equals 0, and product that equals 0. All right, all of this I just declaring. So declaring the variables. And then down here, so now we say while I'm going to check something. All right, we say while counter. Oh, hold on, I did something wrong here. So the counter should be 1. While counter should be less than or equal to 20. I'm going to do product. Yes, I can copy this now. So I can copy that. So product multiplied by counter print. Instead of print, I have printf. Printf. And then have that. So when output, so this can be %d for bringing the equal. There's something wrong. All this should be in brackets. %d equal %d. I have a comma here, so then I have counter. All right, so this is saying I can finish it by putting a semicolon here. So this should have a product. So each time we're going to have product multiplied by the counter to calculate the product. Then down here, so now we're going to have I see a problem. Down here, so now we're gonna print out literally 5 multiplied by whichever number the counter is equal whatever number the product is. So we're gonna have So we have counter. So counter going to take the place. This counter going to take the place of this here, so and product going to take the place of whatever there. So you get that?
Yeah, man. Yeah, man. I understand that part.
All right. Okay, but there's one problem with it though. You see the problem?
Not exactly where it is.
All right. This, or each time it goes around, for our here, so now we'll calculate the product. Product are going to be 5 multiplied by counter. Down here, so now we're going to print out the product. Print out all of this literally, and then we'll update the counter. When I update the counter the first time, the counter got turned into 2, right? So we're going to go around, counter going to start off as 2 here, so. But what product going to start out as? Oh no, it's not a problem. It's not a problem. Because I was wondering if product, the same product, would they here, so?
Yeah, when they so update.
It have got,
Sure,
but it now got real update. 'Cause each time it's a calculate afresh. Each time it's a calculate from scratch. 5 multiplied by whatever the counter is. So that's good. I could try to run it and swap.
Yeah, that seems to match right something, but go on first.
So I could try to see it on the desktop. I say today the 2nd of November. All right, printf. So the problem is already. Never have no bracket here, so. All right, run it as well. Okay. Something's wrong with it. So I could need it up and then see what the problem is. Oh no, it's not wrong. See the problem. Each time I do, go to a new line. Compile, run. All right, 5 1s 5, 5 2s 10, 5 3s 15, 5 20 100. See where All right, okay, look on it using the for loop now.
Only we are not seeing the
Wait.
outputs.
Oh, I'm
Yeah,
sorry.
I just take a sec.
Sorry. Stop share. Let me just share the whole screen then. Share entire screen. All right, I'd run it before. You saw when I run it before and had that error.
Yeah, you see the error, but I don't see the output
Okay.
afterwards.
Okay, it's all right. All right, let me show you what I had before. Hold on there. All right, sorry about that, guys. So no, all right, this is what I had before. Let me compile it again and run it. So this is what I had before. Everything mixed up. So I realized that
Oh,
we just never have, we never got to the new line. So I'm gonna put the new line thing here. So just backslash n for new line. Compile it again. I run it again. Let's see that. You're seeing it now, right?
yeah, you can see it now. Wait, 1 second. You can clear this out, but let me see a code 1 second. I have some issues with. Oh, let me see it. I'm trying to.
All right. The good thing about this the good thing about this, which would not make the for loop be of any advantage over the while loop, is that this is using the counter inside of the calculation, whereas the for loop always use a counter in the to generate its loop. But just for the sake, we now want to run the for loop as well, so at least we can compare the differences. You go do that?
Yeah.
All right, so okay, I'm gonna go back to my to the other editor. So this are the while loop, and so this work. I'll just copy the first part here. So start, stop. Number equal that, everything is the same. Well, here, so we don't need no counter, because the for loop always define the counter inside of the loop. So for the for loop now we have for counter, because the for always needs a counter. Whatever you want to call it, you can call it counter, no matter what we call it, but it needs a counter. It needs a verb that's always incrementing for 1, 2, 20, do. And then down here, so now EndFor. And everything is pretty much the same now. I'm just going to copy everything. So everything is the same. You have product, calculate the product. You go and print out whatever. So we have the same variable counter here so already. And we have it here, so still. So everything remains the same. So we could just compare, and of course, oh, this is the only difference, because you wouldn't need to update counter anymore, because all of that is taking place right here. So in the pseudocode, you see it? So
Wait, repeat what you just said?
all right, so I'm saying everything will remain the same. We're still going to have to calculate all right, this is saying for counter equal 1, say it create the variable counter and it start off by 1, initialize at 1. So it says from 1 to 20, that means they're going to go through 20 times. From 1 to 20, do. And we're going to do the following. We're going to do everything we're in here, so everything we're between here, so we're going to do. So similar to the first example, we're going to calculate the product. Product equal 5 multiplied by a counter. We're going to use the same variable counter here, so. And then now we're going to say print, similar to the first one, print out 5 multiplied by and use the same variable counter equal product. We'll just calculate the product here, so. But yeah, but what I was saying now is that down here, so now in the while loop, we had counter equal counter multiplied by, counter plus 1. In the pseudocode, we don't need it, because all that this take place up here, so in the for loop already. The counter automatically increment up here already. You understand what I said?
Yeah, I see that now. I see.
Yeah. So no need that. So the pseudocode actually is shorter for the for loop than in the while loop, but just by one. Just by one. Let me shrink it down and compare them. Hold on. Put two of them together. So this are the this are the while loop, and this are the for loop. Sorry about that. This Hold on. So this is the for loop. This is the while loop over here. So this is the for loop. In this case, the for loop just slightly less. Or look how it's looking at see now. You get it though. You get the for loop.
Or not exactly, but I'm sorry, I thought about the
Oh, when I get about the for loop, or it's a for the for loop. The way the for loop is designed, it's designed to be run X number of times, and you get to
so when you
determine
state
what.
it one time, you don't need to over it again.
Yeah, you don't have to
You
do
need to
anything.
like add nothing.
Yeah, so that's how the for loop is
Oh,
designed. So really a question like this, ideally, the for loop is ideal in a question like this because you definitely know say I go through the thing 20 times already. You see what I say? And
yeah.
so once we do it here, so when I feel we run through it again for the rest of the program, like how we have to do it for the while loop here so again. The only thing is that this is a simple program, but just imagine a very complex program, like an automated program, in a factory or something like that, or even a security system where you know, sir, certain things are gonna happen after X number of intervals. So after 24 hours, so you're going, all right, suppose after 30 days, you're going to wipe off the tape off of the security thing and restart. So in a case like that now, instead of having to have the same device calculate how long it'll take and then wipe off the thing by using a for loop. Because we have to go say for whatever. And we're going to have to each time we have to calculate the time. When you go down here, say you have to calculate the time. I remember say the time will update every second, you know. So you're gonna count the seconds until you know how many seconds in 30 days. So for each time now, unless you're gonna pull the system time, but you still have to go do it every time, each and every time there's something, you're gonna have to pull the system time and then go over again while until seconds equal how much 1,000 if you execute using the while loop. As opposed to the for loop now, where you know exactly how many times, or you know exactly how many times, what interval you're going to run the thing until you're going to have to do something else. You understand?
Yeah, man, I understand.
Yeah. I mean, the example kind of clunky, but I mean, all I'm trying to say is that in the real world, in a more complex system, we definitely see the advantage of the for loop over the while loop. In some cases. All right, but really and truly, the for loop is way more versatile. Okay, you can do a lot more with it. All right, could try run this and see. And so you know, I'm not even remember. Did we do any for loop in a C? All right, so on.
I'm not sure.
So on, pretty simple. So this is one example. What would they do in a C? All right, come over so to the way. What out of the way? So we're going to do the same thing in a C. That out of the way. And move this out of the way. All right, so when copy the same thing. The for loop, then save it as something else. Save as for loop. This is a different one. So we'll replace that with this. This is the for loop implementation now. Hold on. Writing copy. All right, so all right, we could go now. What is this? All right, so say so no, definitely all right, could go from scratch. So we have that. So we're going to define, we know, so we're going to define the integer int number. Need a number. We need number equals initialize it, and we need a product. We'll initialize the product as well. As I said, when I need for yeah, in this case, for use it for implement the C now, we definitely need for initialize the counter, because the for loop doesn't have any magical way of just creating a variable. So we have to define the counter in the for loop. But technically we could have done it, or could do it two ways. Could do it the safe way first. So going in initialize that 0. Afterwards, I'm gonna show you what I mean. Because I think you can define it while you're doing this. All right, so this is the structure of the for loop. For whatever happened here, so open quotation, end quotation. So we already know. So we're going to say counter is equal to 1. If we initialize it, quotation mark, counter less than or equal to 20, quotation mark, counter plus. To be honest, this make the while loop look simpler. But anyway, so this is what we're doing here. So we'll say counter equal 1. We initialize the counter. Similar to how we're done the while loop. Then we say counter less than or equal to 20. Again, similar to the while loop. And then here's how we increment the counter. And everything. So this is the structure of it. So we initialize it. We state the condition, or this I got define how many times it run, and then here so now it got increment. It have to increment, or else the while loop is have no value. You get it so far?
Yeah, I understand what you're saying.
Yeah, it's just for work. Understand the structure. So here so now everything will be the same. So when it's a product equal to 5 multiplied by counter. Because we have counter, that's how we could have use it back. All right. And we know so this line here calculating product. And then down here, so now we have, hold on, somebody calling, give me a sec. All right, sorry about that. So down here, so now, what's the next line now? We'll have it up here, so. So we say print, so we're going to print out whatever this is. So I'm going to say print if, put in a new line, okay, look at clearer. I'm going to say print if,
Basically, same thing here right back.
yeah, exactly the same thing. So printf, so say 5 multiplied by, put a percentage d, if we call it the counter variable, equal to percentage D, collect the other variable, and then comma. I will know say first variable is counter, and the second variable is product. And we know say from the experience the first, and we'll put a /n for new line here. So each time it happen, go to a new line. So you see the difference between this and the while loop is that we not have any we not go increment the counter here, so because everything happen up here already. You see it?
Yeah.
Yeah. So all right, McQuay.
Yeah. So,
McQuay compile this. All right, to compile. All right. Could run it now.
see screen. Oh.
Yeah, we just compile it so far. I'm gonna run it. So I'm gonna run it now. So we get the same thing.
Run alright.
Yeah. So different methods, same result. We could have used a do while as well. In a matter, as long as it's two things I go after. The first one is, I think the first one is accuracy, and the next one is efficiency. Because you could have, obviously, we could have done it another way. Not sure. We could have each line. We could have print. We could have instead of using a loop. We could have done this 20 times. Not true. How would I get the answer? So yeah, but it wouldn't be efficient. It would have been accurate then, but it wouldn't be efficient. So it's two things we'll go after. I think number one is accuracy. Because if I do a program, like hear how stylish it is, if you're not accurate, I mean, it'll give bad results. But the other thing we'll go for is efficiency.
The error asks, we miss.
I don't know.
You can see chat, but you can step away for a bit.
Yeah, me just earlier. I don't know where I miss error. I did it in while we did it using the while loop first, and then we do it using the for loop. So this is the for loop. But both of them yield the same result. What I was saying before, see, I think this can be done, instead of declaring the counter up here, so let me try it. Instead of declaring the counter up here, so I think the counter can be declared inside of the while, the in here, inside of here, so. So let me comment out this. I'm gonna comment out this and then put int and look if it works. I think this can be done. So for int counter equal that. Say declare the counter from in here, so compile it if I not so. Or so I'm not getting an error. So I'm gonna run it. Yeah. So that can be done as well. You saw me do?
Not exactly. Did I try write the code for what
No.
the header? See.
Yeah, what I'm saying, me take out the counter out of the way how I initialize it the first time.
Yeah.
Out of the top here, so. Because all this is doing, is declaring an integer, is declaring the counter as an integer and initializing it with 0 up here, so. But down here, so now, instead of doing that, all I'm gonna do is put int counter. In other words, we initialize the count, the variable in here, so in the for function.
For loop.
Yeah.
Okay.
You see? I mean, whichever one. Whichever one. It doesn't matter. It don't matter. But I mean, whichever one you feel comfortable with. As I say, step number one is accuracy. And see.
The first int though.
No, because int. Yeah, because int I deal with these already. All right, let me take it out totally. But this, so no, we never declare int yes at all. I know here's when we declare it. If we never have it here, so.
Oh, see. Oh yeah, there represent counter there, so.
Yeah, if we never have it here, so would that be an error? Because the programmer got asked one name counter.
Right.
Yeah. So of course we could have make it a float, we could have do it with we could have make it anything, but the whole program itself. has it as an integer. So so that is the I could try to run the flowchart and see how it relates. But I can't remember how it go. Draw back for the nodes so we get. This is the while loop. This is the for loop. Did they give us example though? For loop continued. Okay, so this is the structure of the for loop. When Mr. Monday, where the teacher give it. So it is. We could try it. Copy this and so on. Here, let me just create a new line here, so a new slide. Delete all them extra stuff, yeah. And copy the pseudocode. Which one of them you want to run? Both of them? Well, the while loop and the for loop are in one.
Anyone.
All right. Try the for loop because I'm less familiar with the for loop. All right, so yeah, start with this. I'm just putting a text box. It's always before our eyes. Reduce the font size a little. Take off all of them extra something. Just bear with me, I take off the excess baggage. All right, that should be us. EndFor. And stop. All right, so you don't need to know. Use a full work with. So no, so we start with a start with the start. And so let's look at what time now? 3:16. What time class supposed to finish? 4 o'clock.
4.
All right, okay. Just run through this and done. Then I call this the shape fill outline. All right. So start. Oh no, definitely we need to stop. Use red color, say use FSC. How does this? All right, so now we have a start and a stop, and then here, so now put them in a box. Oh, geez, I forgot to show the same thing. So we'll say, so them and now are going there. Number equal that equal that. You make it smaller. So resize it. And then we say now counter is equal to 1 to 20. Hold on, how did it? All right, you see the difference with flowchart. No, the flowchart actually look like the for loop, you know. The for loop, let me explain what I mean. Based on this example, the condition more resembles C than it resembles pseudocode. I'm gonna copy this. All right, this is the example that that we got. This part now, this part I was supposed to have the condition here. So you notice the structure is different. It's supposed to say less than or equal to, similar to how we had the C. Let me show you exactly what I talk. All right, I'm gonna copy this so we have. It's so different. It more look like the while, you know. It more look like the while. Oh yeah, see it here. So it's a counter here, so. It's a here, so the part here. Counter less than or equal to 20.
Mm-hmm.
Yeah, this is how it is, you know, we call it now, the flow chart.
This is one section. That's all.
Yeah. So this is how it more resemble. So the flow chart more resemble C than it does resemble the pseudocode. Is that what I said?
Yeah, I'm sorry, that's the one.
Yeah. So it's just for
Yeah. I'm just say I really same thing though. Like the pseudocode flowchart, told them show you same thing. It's just that how we write it.
yeah, exactly. It's just how you write it. Or I could clear all of this. So I could have this. So this is our C program. All right, now so put this one side. So we know we have num equal this, that equal that, and we definitely need a counter. We need to declare the counter as well. Counter. Spell it wrong. Counter equal 1.
Yeah, it's one.
So it almost resembles exactly the while loop, almost. Almost exactly, doesn't it? You know what? Almost exactly. It's almost
Basically,
basically while loop. Not sure.
yeah, basically hit that.
Hold on, okay, get the
Funny right now.
get the while loop. Get rid of all of them. Copy it.
The section we have the integer, we are declare the numbers.
Almost look exactly like the while loop. This is the while loop. Yeah, almost exactly well. You know why I'm saying that? Because down here, so we have to increment the down here, so we'll have to increment. Where is it? I look for that pointer somewhere.
We have counter equal counter plus 1.
Yeah, yeah. Down here, so we have to increment the counter. You see, we have to increment the counter using the for loop.
Yeah, so you can draw it. Yeah, right, my side, that's why it's like the same thing.
Yeah, so it more, even though it's a for loop, it more resembles the while loop. I look at time, I say, hold on, we hardly do for loops. All right, anyway, okay. That's why practice is all important. All right, I can put that one side. So now so we have the diamond. Put the diamond, look for the diamond. Where is it?
Go down somewhere. Yeah.
Don't like how this look at all. I want to say counter. Counter less than or equal to.
Equal to 20.
And then down here, so now we do down here, so I get more calculations. Copy this. So this is a product. And call 5 multiplied by, could I just copy it and I'll 5 multiplied by counter. Spell right. 5 multiplied by counter. And then we're going to print something now. So we need the other flowchart something. I want for input, output, then we're going to print. I just copy it from here, so the same exact thing. Reduce the font, say at least can fit. Change the color. No error. We just see a message. She never mentioned Excel test. No, because she wouldn't have. Because remember, today we were supposed to have done the presentation. Unless you mention it without my knowing.
Next week is the presentation.
Yeah, I heard that. It's just that Ara is asking if we have if she had mentioned a Excel test today.
I think so. No, sir.
All right, and then now the last thing for us to do now is the increment. Well, it's not the last thing. For increment the counter. Counter equal to counter plus 1.
Counter plus 1.
And the only thing now for do is put in the algorithm and so on. So
yeah.
So what me usually do with this, I just reduce the font size. No, so I need more space. Shrink down everything. Well, really and truly, me usually put arrows in while I do it, but
Use PowerPoint though.
it really, well, it's one step up from Microsoft Word. All right, there's one slight difference with this now, where could arrange them now. That gives them neat. I think gonna align. Where is it? Align. Align them centered. All right, so I have that. Align them vertically. Distribute even vertically. All right, so we'll have that. All right, so now if we put in, we'll line them now. Put in the obvious line first. Hold on. So everything's supposed to go down straight same way. So if the condition is true,
We still have to duplicate ours. Or copy and paste it too.
Yeah,
Really?
copy and paste it. Copy and paste it.
Oh,
Yes, we don't need this no more. So come move this out of the way, little, move it over. And then now this saga loop, based on how this, since it's so similar to the while loop, is after this is the last thing will happen. The counter. After the counter, that is when it loop again. Hold on, that's right. So it's after this something, that is when it actually loop again.
oh, you,
So
you
this,
just wonder where to put the arrow. To go
yeah,
after the counter.
which is anything that is just before the closing bracket for the loop, for the while loop,
At the
or
end one.
or in the pseudocode, anything will happen just before the EndFor or the EndWhile, yeah. Anything will happen. In this case, at this, it's just that we needed to increment the counter. So the increment in the counter would have been down here, so and then we repeat it. So the same thing with the for loop. So we know say yes, so here, so now I'll go back round in the and that in there, so we'll go back round above the condition.
Top of it. Yeah.
I remember each time I gotta test the condition, which is this.
And then from there, so now it would go all the way down to stop
Yeah.
when it
So
actually reaches 20.
yeah, so this once it's true. This I gonna happen once it's true. After it reaches 20, it's gonna fast, and this is when you go down there, so now. So the stop I got actually there, so stop. Can't write with mouse. Yeah, so I'm going to clear all of that now. Clear all of that and do it. All right, so how I usually do it in a PowerPoint. I guess the app that was shared last week is the way for is easy of use, but for now, use PowerPoint. So I'm usually do I put a little box here, so I have something for the arrow stick to. And then now we just need this arrow come here, so go all the way and stick it there, so I'm gonna stick here. If more, I can move move it out of the way. And then down here, so now move the stop over here and do the same thing and get it again from us. So carry this on. And then I'm gonna label it and say this up, put a label box, the text box. Can tell word sure put T. It's smaller. So this happen when it's true. Put it so. Can put in a color so we actually see it. So that happens when it's true. And this happens when it's false. Yeah, when it's false, that happens. And then now, one thing if I don't know, I just remove that. Or no fill. And that is we. All right, so this is it. This are the pseudocode. This are the C implementation, and this is the flowchart. That's it. I know we're done. Although the question only asks us for this, but at least by doing this, we see the connection between all three of them.
Yeah.
Yeah, and that's how we.